have completed two chapters, chapter 3 motion in a straight line and chapter 4 motion in a plane. Okay, yes, in chapter number 3 and 4 we have discussed only about motion of object, only about motion of object, not its cause, not its cause. But now you may ask some questions, okay, why objects are in motion, why they are performing linear motion, why they are performing rotational motion, oscillatory motion. So what is cause of motion? So yes, in this chapter, chapter number 5, laws of motion, we will study how object comes in motion and what is required to bring object in motion or to stop its motion. Okay, see, if we start from some routine work, okay, if I have a notebook, on bench, and if I want to displace that notebook, obviously I have to give some external agency that provides force. Means with the help of hand I have to give some force to move that book. Simple. Yes, if some object is moving, for example one ball is rolling, means it is in motion. To stop that ball, yes, again I have to apply some external agency which provides force to stop its motion. So yes, there are numbers of examples. Okay, if this fan is rotating and I am applying some force, then yes, it will stop its motion. So yes, there are numbers of examples that we have seen. Okay, see, chapter number 5, laws of motion. We have to study about this. First, what governs the motion of bodies? Return to this basic question. Yes, in chapter number 3 and 4, we have only discussed about what is motion. Okay, speed, velocity, acceleration. Yes or no? Yes, about this. But why object is getting acceleration? Why it is moving? Why it stops? We will find in this chapter. See, here it is. Some external agency is needed to provide force to move a body from rest. Likewise, an external force is needed to stop or retard motion. Yes, you know. Okay, if you want to move any object, if you have one toy car, okay, and if you want to bring that toy car in motion, obviously you have to apply some force. Similarly, if something is moving and I want to stop, then I have to apply some external force. So yes, to bring a body from rest condition to moving, or for moving to rest, we have to apply some external force. See, sometimes external agency is needed to provide force to move a body from rest. Likewise, an external force is needed to stop or retard motion. Yes, that is one example. You can stop a rolling motion by applying force against its motion. So yes, what is conclusion of these 3 points? Conclusion is these 3 points is to change state from rest to motion or from motion to rest, something external agency called force is required. Now force, types of forces, yes, there are 2 types of forces, contact force and field force. For example, if I want to move a book from bench, okay, I have to apply force with the help of my hand. I will touch, I will hold that book and then I will move. Yes or no? Yes. If car is not moving and I want to bring car in motion, then yes, I have to push car with the help of my hand. Means there is contact between agency and object. Yes or no? Yes, it is. So there are numbers of examples. If this fan is in stationary condition and I want to rotate it, then with the help of my hand, by applying some force, I can rotate this fan. So see, in this each and every example there is contact. There is contact between object and external agency providing force. Clear about this? So yes, force, first type, contact forces. Contact forces. Okay. For example, to move book from table. Clear about this? Yes. Field forces means what? Field forces means what? See, here it is. It is chalk. If I drop this chalk, it is moving in downward direction. Yes or no? Yes, it is moving in downward direction due to, you know answer, gravitational force. Gravitational force. Gravitational force of earth. So see, this chalk, it is here right now in my hand. Okay, gravitational force acting on this chalk is due to earth, and due to its gravitational force, it is moving in downward direction. Is there any contact between earth and chalk? No, they are not in contact. Another example, see, if I have magnet in one hand, or if I have magnet on table, if I have one magnet on table, North Pole and South Pole, and I have iron filings, iron particles like this, then you know that due to this magnet, these iron particles will be attracted towards this magnet. Yes or no? Yes. Is there any initial contact between magnet and these particles? No. No contact. No contact. If you have magnet and some conductor piece near to it, not in contact, then yes, we know that it is attracted towards it, it will move. It will move. So yes, field forces. Field forces means object experiences force due to field. Object experiences force, it is moving due to field. Such fields are, yes, gravitational field, then it is magnetic field, then it is magnetic field. See, magnetic field is easy to understand. You know the basic experiment of magnet and iron fillings. Magnet and iron fillings. Without any contact, iron fillings are moving towards magnet. Clear? So it is about field forces. Yes, electric field. So such fields are called forces. Acting due to such fields are called field forces. In such forces, there is contact, it is without contact. Clear about this? Okay, so what is conclusion? In short, a force is required to put a stationary body in motion or stop moving body, and some external agency needed to provide this force. There is force required to bring a body from rest to motion or from motion to rest. It may or may not be in contact with body. Yes, we have discussed there are two types of forces. Okay, now see, if I picturize this statement in form of figure. See, if one body is in rest condition, means its velocity is 0. Yes, I am applying some force. Yes or no? Then body comes in motion. Means its velocity is not 0. Clear about this? Means see, in this case there is change in velocity. And change in velocity means it is accelerated motion. Yes or no? And accelerated motion is also called non-uniform motion. It is also called non-uniform motion. Clear about this? Another example, if object is in motion, means its speed, its velocity is not 0, then to stop or retard this object, we have to apply some force. So it will come to rest, means its velocity becomes 0. Again, there is change in velocity, means it is accelerated motion, means it is non-uniform motion. So from this discussion, it is clear that for non-uniform motion means to bring object from rest to motion or from motion to rest, we have to apply some external force. We have to apply some external force. For this non-uniform motion, we have to apply some force. Clear about this? So yes, now you may ask me one question. But what if a body is moving uniformly? Means if a body is moving with uniform velocity, is there any requirement of force? If body is moving with uniform velocity, is there any requirement of force to keep that body in motion? That we will see in next topic. Okay. Now we know that for non-uniform motion, means when velocity changes, force is required. You know examples. So yes, we have one question. Is there any requirement of force for uniform motion? To keep body continuously in motion, is there any requirement of forces? First argument was given by Aristotle. See, title of theory is Aristotle's Fallacy. The great thinker Aristotle held a view that if a body is moving, something external is required to keep it moving. It means an external force is required to keep a body in motion. Okay, now if I am taking one example for this Aristotle's statement and how to understand this. See, Aristotle argued that if it is bicycle, if I want to move this bicycle with constant velocity, I have to apply pedals continuously. Yes or no? If I want to move this cycle, uniformly, I have to give external force, means I have to apply pedal. Yes or no? If I stop pedaling, cycle also stops. And yes, you will also say that sir, it is right. It is right. If we apply pedal, cycle is moving. If we stop applying pedal, cycle will not move. Then why it is stated Aristotle's fallacy statement, its argument is wrong? We will check this. First of all, Aristotle's fallacy. What is argument given by Aristotle? The Greek thinker Aristotle held a view that if a body is moving, something external is required to keep it moving. An external force is required to keep a body in motion. Means I want to move this cycle uniformly, then I have to give force. I have to apply pedal. Pedals are required to move that cycle. Now what is wrong in this argument? See, what is flaw in Aristotle's argument? Yes, in nature, we know that there are some opposing forces. For example, which opposes our motion, it is called friction force. In case of fluids, that opposing motion for fluid, it is viscous force. So yes, whenever objects are in motion, this type of retarding forces, opposing forces, opposes motion of object. And to continue motion, we have to give some external force. To continue that motion. See, a moving cycle comes to rest because external force of friction on the cycle that opposes its motion. Yes, you know about friction. Okay, To counter this force, the child has to apply external force on cycle in direction of motion. Now understand what is difference between these two statements. Aristotle argued that pedaling means force is required to keep cycle in motion. But what is reality? Reality is we have to apply force to overcome friction force. To overcome friction force. If force of friction is equal to external force applied by a child, total force will become 0, and total force 0 means acceleration 0 means velocity constant. That cycle will move with constant velocity. So yes, what is right argument? Argument is we have to give force to counter that friction force. Okay, when cycle is in uniform motion, there is no external force acting on it. The force by the child cancels the force of friction. The force of friction. So yes, here we have to apply force to counter the opposing force. To counter the opposing force. And when total force is 0, acceleration 0, cycle will move with constant velocity. With constant velocity. Clear about this? Yes, in nature, the opposing forces such as friction and viscous force are always present in the natural world. So, to overcome these natural frictional forces, to continue its motion against these opposing forces, we have to apply some forces. This explains why forces by external agencies are necessary to overcome the friction forces to keep a body in motion. Yes, what is wrong in Aristotle's theory? Aristotle coded his practical experience in the form of a basic argument. In the form of a basic argument. Yes, at first sight, you may be thinking that this statement is right, but see, it is one practical experience. What is actual reason behind it? This one. Okay, we have to apply force to overcome friction forces. To overcome friction forces. Clear about this? If there are no friction forces, then yes, we do not have to apply any external force. Clear about this? So yes, in today's lecture, we have discussed about 2 points. First, what is force? Types of forces. Okay, and when force is required. Second is Aristotle's fallacy. When object is moving with uniform velocity, is there any requirement of force? And why it is required? That we have discussed in this topic. Clear about this? Yes. Chapter 5. Laws of motion. It is one important chapter in physics. Okay. Because the concept, Newton's first law of motion, second law of motion, third law of motion, law of conservation of momentum, okay, frictional forces, then free body diagram, okay, these important questions, these important theories from this chapter is also helpful in another chapters and in 12th. So yes, you have to watch proper video, make notes. If you have any doubt, then contact me. Okay, and yes, at last, do not forget to share, subscribe and like our channel and our videos. Okay, thank you.